Hey, I'm Mitchell, and welcome to another video in the RSP Educational Series. Today we're going to talk about what makes your motor smarter, safer, and way more efficient. That's why we're getting acquainted with the powerhouse of modern motor control, the variable frequency drive, or VFD. From saving your motor from an overload meltdown to slashing your energy bills and boosting productivity, VFDs are a game changer in industrial automation. Here's what's coming up: how VFDs protect your motor, why they're the ultimate energy savers, where you'll find them at work, and why every smooth start and stop is a win for your equipment. Stick around, because by the end, you'll know exactly why a VFD might just be the smartest tool in your industrial toolbox. As always, if you like this content and want more educational videos, please like and subscribe. Also, this video is for educational purposes only. Always consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get right into it. Last time we talked about soft starters. Today, it's all about VFDs. If the soft starter is your slow and steady option, well then the VFD's your Swiss Army knife that can do it all. Whether that's speed control, torque control, energy efficiency, motor protection, let's learn the basics. So a variable frequency drive, it's an electronic device that adjusts the speed and torque of an electric motor by varying the frequency and voltage of the electrical power supplied to the motor. This is used instead of a motor starter or a soft starter for many reasons. A motor starter simply starts and stops the motor, leaving it to operate constantly at full speed with zero control over the speed of the motor. A VFD, on the other hand, that's going to control the speed and torque of an AC motor by varying the frequency and voltage supplied to it. This allows the user to hone in on precise control over motor performance. Think of it like a light dimmer for a motor, where a starter would just simply be an on and off switch. Let's talk reasons why a VFD would be needed. Energy optimization. So in many automation systems, these are going to run off of motors that don't need to be set at full speed at all times. A VFD adjusts motor speed to process demand, significantly reducing power consumption. Precision and process control automation systems often requires motors to operate at variable speeds to match the exact process requirements, like in conveyors, mixers, robotic systems. Soft starting is one of the key features with VFDs, and they're essential in automation to avoid mechanical shocks, to protect load-bearing systems, and to ensure smooth transitions between process states. Reduction of downtime and maintenance is provided by VFDs by providing soft starting and stopping. VFDs are going to minimize wear and tear on motors and connected mechanical components, and that's a critical factor in uptime for automation systems. Scalability and flexibility, that's a unique feature of VFDs. So they allow a single motor or system to handle various tasks by adjusting speed and torque dynamically in real time, reducing the need for multiple fixed speed drives or different machines. So how does a VFD work? It's powered by an AC power input. So the VFD receives standard three-phase AC input like 480 volt or 60 hertz from the industrial power distribution network. Then there's rectification for the second step. Inside the VFD, there's AC to DC happening. The input, AC, is rectified into DC, creating a more stable and controllable energy source for the motor. DC bus or storage. The DC bus is going to smooth out fluctuations, ensuring that the automation systems requiring precise motor control are going to receive stable power for consistent operation. Then there's inversion from DC to variable AC. The DC is converted back into AC at a variable frequency and voltage using an inverter, which is controlled by microprocessors or digital logic. Then finally, we have the output to the motor. The VFD is going to send the newly created variable frequency AC power to the motor as its final product, and that's going to adjust its speed and torque as needed. So with VFDs, frequency is what's actually going to determine speed. A motor's speed is measured in RPMs, and it's proportional to the frequency of the AC power supplied to it. For example, you have a standard 4-pole motor running at 60 hertz that operates at 1800 RPM. This allows process rates like conveyor speed or fluid flow to be precisely controlled. Voltage to frequency ratio is a task also that VFDs perform. They maintain a constant ratio of voltage to frequency to ensure efficient motor performance. Energy management is also tackled by VFDs in automation systems. They contribute to overall energy efficiency by operating motors only at the power levels required by the automation process. Dynamic braking is another function of VFDs. They can slow down motors quickly by dissipating energy through resistors or regenerative techniques. Closed loop control. That's where VFDs interface with sensors like encoders or flow meters to receive feedback in real time about the motor's performance and make real-time adjustments on the fly for precise process outcomes. Another great feature of VFDs is their seamless integration with PLCs and SCADA. They're going to communicate with automation controllers like PLCs through industrial protocols like Modbus, different kinds of Modbus, Ethernet IP, Profibus, many more, enabling centralized control and monitoring. Where will you see VFDs used? Key applications in industrial automation are going to be conveyors, where VFDs are going to adjust belt speeds depending on product flow or production rates. This eliminates and reduces bottlenecks in systems. Pumps and fans, right? These are lots of times integrated in HVAC or fluid control or cooling systems. VFDs are going to adjust speeds based on demand, often using sensor feedback. Robotics is a big one. Precise motor speed and torque control enable VFDs to drive robotic arms and manipulators in automation systems. Packaging systems. VFDs are going to handle dynamic speed adjustments for seamless coordination between different machines like filling, sealing, labeling, cranes, and hoists. Real-time torque and speed adjustments ensure smooth and safe material handling in automated operations and lots of automated warehouses that's applicable. So some benefits of using VFDs, like we discussed, their dynamic process adaptability. They're enabling automated systems to adapt to changing conditions in real times, like varying loads or speeds with minimal manual intervention. Reduced energy footprint. Energy efficient motor operation is going to reduce costs and support sustainability goals for automated facilities. We want them for extended system longevity. By minimizing motor stress, VFDs are going to ensure longer lifespans for critical automation components. Centralized monitoring and control. That's a huge one that starters don't have. So integration with control systems is going to ensure visibility into motor performance and simplifies troubleshooting. That's it for today's beginner introduction to VFDs. Hopefully you understand at a basic level what VFDs are, how they work, why they're absolutely necessary in industrial automation. Stay tuned because we will get deeper into the details of VFDs and learn about them on a more technical level in a VFD series to follow. For a full line of VFDs and hundreds of thousands of other industrial automation products, go to our website. Also, for more information and other educational videos, please go to rspsupply.com, the internet's top source for industrial hardware.